So this session is really about quantifying the climate benefits of the circular economy. And what we have today is a really interesting, quick series of examples of how circular economy can be used in thought and strategies and examples of businesses actually doing circular economy and quantifying those climate benefits of their actions and their value chains. So I don't want to take up any further time, and I'll just introduce Calvin, who's joining us today as the host and moderator for this session in particular. He's with the Canadian Climate Institute, and I really appreciate Calvin jumping in for Rick, and we'll introduce how the session will run and who's up first. So Calvin, over to you. Thank you very much.
Can you hear me? Great. So yeah, thank you all for coming for this session on quantifying the climate benefits of the circular economy. My name is Calvin Trottier-Chi, and I'm a research associate with the Canada Climate Institute, Canada's leading climate policy research organization. We produce rigorous research and evidence-based, nonpartisan climate policy recommendations. Recently, we released a new report on the emissions reduction potential of circularity in Canada. And what we've seen is that circularity has significant but underutilized potential. Historically, climate policy has typically been framed as a matter of the energy sector. It's often framed as a transition from coal mines to wind turbines, from drafty houses to well-insulated ones, and then just capturing the rest with sequestration. But as we know, the economy is far less linear. Different sectors influence each other. And if we account for the economic reasons behind energy use, then we can say that up to 70% of emissions are induced by material demand. Climate policy is starting to include circularity in its climate targets. Already, 79 countries directly reference the circular economy in their UN NDCs, including Canada. However, Canada only references it in the context of BC, and we know better than most that setting targets alone is not enough. After all, Canada has not met a single one of its climate targets since it first started setting them in 1990. This time, it's looking to be different, though, because this time, we have a secret weapon: rigorous quantification. Last year's 2030 emissions reduction plan was a watershed moment for climate policy, because it not only set a target, but it set a target based on quantification of where emissions are and where they will be reduced. So it's my hope that we can have our own little watershed moment here today as we push climate calculus a little further with circularity. So it's my great pleasure to welcome to the stage 8 amazing experts who've all done work on making the benefits to material and climate better with circularity. So please welcome to the stage Thomas Elliot, postdoctoral fellow at Ecologie de Technologie Supérieure, Gualandris, feel free to come on if you'd like. Gualandris, Associate Professor of Operations and Sustainability at Ivey Business School and Director at the Center for Building Sustainable Value. Ryan Zizzo, Founder and CEO at Mantle Developments. Darryl, Director of Sustainability at Kaltire. François Saunie, Deputy Director at the International Reference Center for Lifecycle Assessment and Sustainable Transition, or more commonly known as CIRAIG. Sayegh, Senior Sustainability Engineer, and Yoon, Energy Sustainability Consultant from Arup, and Julian Cleary, Senior Policy Analyst at Public Services and Procurement Canada. You'll soon You will soon be hearing from them all in 7 7-minute presentations, after which there will be 20 minutes for questions. And I think we have someone walking around with a mic, or also feel free to submit the question on the app. I'll be trying to monitor it. But first, we'll be hearing from Thomas Elliot. Thomas has a background in energy modeling, life cycle assessment, and ecosystem services. His recent work has focused on the circular material flows in the Canadian construction sector. And Thomas, the floor and the podium is yours.
Thanks, Calvin. Great, so thanks for having me here at this wonderful summit. I've heard a lot about business and about innovation in the last day. So I'm going to talk about environmental science. I'm going to talk about the teleconnections, what happens to the spatial trade-offs and environmental impacts, 'Impacts' 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 There we go. So a city has a metabolism, requires resources. These resources tend not to come from the city. They come from places in the province, perhaps, or in the rest of the country, and many times they come from different parts of the world. So tracing back these environmental flows to see where resources are extracted from, and then understanding where the environmental impacts of those resources are located is really important when we think about when a city becomes more circular. So when we start to use some of our wastes and they offset the environmental flows that are coming into the city, what then happens to the environmental impacts around the world and who benefits from these? So I'm modeling this using a material circularity indicator that was developed by the Ellen MacArthur Foundation and ANSYS grantor. So the material circularity index or indicator, this is a little bit nerdy. So this is just a way of capturing all the virgin materials that come into a product system and all the waste flows all the way through that supply chain. So there are wastes in the manufacturing and the transportation delivery of the product, and also then at the end of life, of course. So trying to minimize that W, the waste material, and the virgin material in it will give us the best kind of material circularity. So that's just a formal way of describing the increase in circularity inside a city or a product system. And I'm going to show you what happens when we increase the material circularity indicator over time in a city, and where the environmental flows change, and then what we should do to mitigate any subsequent unintended consequences. Right, so I'm looking at a case study in Montreal, which is where I'm working, and I'm looking at a period between 2017 and 2050, right? So about three decades of changing demands in the construction sector specifically, and with 9 different material categories. So the construction sector is using these 9 different materials, but over time, I'm going to look at what happens when we implement changes to the demand, and what happens to where these impacts are happening. So if we increase the material circularity from 2017 to 2050, you see the little dots, the blue dots and the green dots. Blue dots are where we were at in 2017. If you look at that, those are on the axis on the right side of the screen. They can increase. This is the potential for increasing the circularity of all of these 9 different product categories. So of course, the theoretical maximum is 1, but we don't get there. Some materials don't change because according to the information that I had, it's quite hard to make some materials more circular, for example, concrete products, but I did hear something interesting yesterday about reusing concrete. And down the bottom of the screen, you've got just the portion of where these products are coming from. So you can see that a lot of them, a lot of the products that we use in Montreal are coming from the rest of Quebec, and that changes for the different material categories, right? So for example, lime is sort of half from Quebec and half from the rest of Canada, with a very small part coming from the rest of the world, whereas plastic is like 3/4 from Quebec. All right, so that's important because that then helps us understand where the environmental impacts are happening. When we model out to 2050, we see that when we compare across different environmental impact categories, so you've got acidification, metal depletion, which is sort of quite closely related to materiality, global warming, of course, climate change impacts, greenhouse gas emissions, and down the bottom on the right, you've got water depletion. So these are really important environmental impact categories, and we see trends across all of them in these 3 decades of forecasting where they improve. The increasing in the blue shading is a relative decrease in that environmental impact category, and the pinky reddy color is an increase in the environmental impacts, okay? So if you look at the inset for Montreal, let's say for terrestrial acidification, you see that there's an increase there over the 3 decades. That's a result of the displacement of production activities in different parts of the world, then being relocated into sort of recycling processes inside the city of Montreal. But as you see, there is a lot of benefits that happen around the rest of the world. So this is what we call changing teleconnections, right? So those environmental flows are happening now in Montreal. And is that what Montreal wants when we start to try and make policies that are more circular? So I think this is really important for organizing levels, for example, city councils, understand who's benefiting. Are we benefiting because we're altruistic and we want the world to be a better place, or are we benefiting because it's good for our marketing, our branding? We can then sell Montreal as a really circular city. So this session is about embodied carbon. So I've got here global warming. But the point of showing all of these is that the trends are not always the same, or the place that benefits is not always the same. You see with the acidification, there's more worsening there in Montreal than there is, for example, in global warming. So that's just sort of to understand potential trade-offs, and you're probably getting sick and dizzy of that going around, so here's a still version of it, if that makes you a little bit happier, but basically the same information at 2050. So that's sort of the end point of the model. But then what we did next in this research is we looked at the locations of those impacts. They're not all made of the same sorts of economies. They're not all of the same kind of wealth, prosperity. So we compared the countries, their relative increase or decrease in those 4 different impact categories to the Human Development Index. And what we found is there is a trend for the impact reduction, the benefits of these circular policies, this optimal material circularity indicator, to be skewed towards the wealthier countries. So that's not really a good thing. That's a risk, and that's not necessarily what's going to happen. This is an exploratory model. There are a lot of assumptions in there, and things can change between now and 2050. But this is to show that there are risks that we might increase the environmental injustices, because at the heart of it, circular economy is an environmentally grounded movement that needs to increase environmental justice. There is here a risk that the poorer countries that are already suffering from some of the worst environmental impacts are going to reap less of the benefits. So just some conclusions from that. I said this is an exploratory model, so this isn't what necessarily will happen, but burden shifting does occur within these environmental impact categories across different spaces. That means that we trade one environmental impact for another in some cases, and that happens at different spatial levels between Montreal, as you saw in the maps there, and the rest of the world. But these trade-offs are small. So mostly it's a good news story. Mostly there were environmental impact decreases across all 4 of those impact categories and in most of the spatial levels. But this is insufficient, right? We still have, and I showed you these were relative changes, but we still have an increase in environmental impacts. We're reducing what would have been there with a business as usual case if we increase this material circularity indicator. So we still need to do other things to make the world a fairer and more environmentally friendly place. And so I really liked Emmanuel's comment at the end of the last session that we're addicted to growth, and I would just encourage people to think that material circularity and circular economy is not alone enough, and that we need to link this together with other concepts for social change and economic change. And rather than just thinking about how we can grow the economy and use circularity as a marketing tool, that we need to think that this is about fairness at its heart. So degrowth and maybe other concepts similar to degrowth, post-growth, need to be considered within the circular transition. So, thank you very much.
Thank you, Thomas. Actually, I guess I could just say it from down here. Right. Get a better view of the slides from over here. So yeah, next we'll be hearing from Gualandris with an agri-food sector focus. Yuri combines both sustainability and business in his research with focus on supply chains and competitiveness, and through his leadership of both the Building Sustainable Value Center and the Network for Business Sustainability. He's also received research and teaching awards from several leading academic institutions. Thank you, Yuri.
Sorry.
And, yeah. Do you want me to do more introductions while you? No,
okay. All good, thank you. Thank you all. I'm going to present a couple of results from a research project that started in 2019 and it's now published in the Yale Journal of Industrial Ecology. We basically looked at or challenged the idea that circularity is always a good thing. And so we looked at under what conditions actually circularity do well for the natural environment. We focused only on carbon, but obviously there are other dimensions that should be considered. So briefly, I wanted to sort of give an overview and sort of a pitch of what we do at the Ivey Center for Building Sustainable Value. We are a very well-known institution in academia, and that's why I moved from Italy and Europe to join Ivey 6 years ago. My second daughter now is Canadian, which was not planned, but fantastic. The problem was that the center wasn't really recognized by industry partners and policymakers as a center that could shape what we do in the country. And since I became a director a couple of years ago, we wanted really to change that. We want to offer research insights that are informing important decisions at the provincial and national level. I'm gonna do this very briefly. So this is the systems change model that the center operates under. We have 5 areas where we hope to help policymakers and industry experts. So we have lever 1 is essentially assessing and quantifying new business model and practices. You have an example of that stream of research today. I'm going to present in a few seconds. Lever 2, how many of you were in the panel just before? Okay, so you have heard a lot about mindset and paradigm shift. That's what we do in lever 2. We have system thinking tools and frameworks that help different players to come together and surface their belief systems and challenge those belief systems towards new principles that can shape the decisions that they make. Lever 3, we focus on financial instruments as we discover new practices that are driven by new principles and mindsets. We also need to adjust our financial instruments such that the money flows where it's needed the most. And so there, for example, we are the first one in Canada. We launched a conservation bond, and now we are replicating it across different areas in the Carolinian zone in Southwest Ontario. Number 4, we are working with the Canadian Standard Association to translate some of these insights into actually standards and guidelines that companies can pick up for a more rapid acceleration of the uptake of circular practices. And lever 5, ultimately, when companies have the right incentives and are given the right standards, they still have to learn how to adjust certain practices to their specific context. And that learning is facilitated based on peer-to-peer information and knowledge exchange. That's what we also help within the center. Now, that being said, this is the network that I've studied that is emergent in Montreal. So essentially, what this network represents, each quadrant are firms, different firms. And from bottom to top, there is the general flow of the traditional supply chain systems, from upstream operations to downstream operations. And here you have 4 companies in yellow that are very active and have been very active in the circular economy. And the green lines are essentially symbiotic exchanges of otherwise wasted materials that sort of create the circular economy in Montreal. So firm A, for example, takes used kitchen oil from restaurants, combines with the residues of juicing, the pulp of fruits and vegetable residues, and makes soap out of it. Another company transforms spent grain into upcycled cookies. Another company takes the spent grain and other residues into feeding insects that then produce frass and produce protein. Another company, again, takes the residual of those materials and turn into energy. So we looked at all of these applications and we asked the question, which one are the best in terms of carbon savings? If we have competing pathways through which the material flow that is wasted should go through, which one are the best pathways and how should they be operationally structured to achieve the best performance results? So we published that result into this study. It's publicly available. You can download it from our website. All the things that we do are publicly available, so there is the sort of share IP. What we did, so there's a summary. We studied 2 areas, Montreal, which is what I showed you, but also Guelph and Wellington County. There has been a lot going on there in terms of agri-food. We looked at upcycle opportunities and waste management opportunities for 2 specific type of material streams, wet spent grains and fruits and vegetable residues. The reason why we focused on those 2 is because they are, in terms of quantities, the most wasted materials in our agri-food sector. And also they have generalizable properties to other materials as well. So there is a good generalizability. We essentially analyzed all the potential pathways based on a large-scale field intervention where we interviewed more than 80 companies and to understand what materials they access to and how they transform this material. And then we have modeled this with LCA, both the specific cases, but also through a simulation where we changed some of the variables to look for optimal results. So if you have to take away one thing from my speech, is what I'm going to say next. This is how we shaped our mindset. This is our food recovery hierarchy. It's a linear solution to a non-linear problem. What happens when you apply a linear solution to a non-linear problem? That this is wrong. So if you follow this sequence, you might sub-optimize the upcycling of food discards or waste streams because under certain conditions, feeding animals or industrial uses are actually more sustainable than upcycling materials. So we looked at that, and all of the results are in our report. We then looked at, okay, but under what conditions upcycling to humans is actually good? So we wanted to determine if we want to generalize across companies and we want to tell them, like, follow these prescriptions. If you follow these prescriptions, you are going to be able to say, hey, I'm upcycling this material to human consumption, and I'm doing it in a way that saves carbon. Because, in fact, the circular economy is not always positive, as I just mentioned, from a carbon standpoint. So here is sort of a graph that shows the range of ecological impact that you can have when you upcycle fruits and vegetables and residues and spent grain. And you can go from the very positive, saving a lot of carbon, but under some configurations, you actually do a lot of harm. And so let's see what configurations are. These are the four key insights from our research. So first one is geographical scale. From when the point of collection of the waste, all the way through your supply chain processes, back into when you deliver the new product to the market, you have to be within 250 and 300 kilometers radius. If not, you are most likely not saving carbon relative to virgin production and linear processes. So the first one is a necessary but not sufficient condition. What is the next necessary condition? Second, as you collect the spent grains of the fruits and vegetable residues, you have to transform them. So you have to dry them, you have to mill them, you have to mechanically press them, you have to package them. So the technological or production configuration of all those activities should consume less than, let's say, 1,600 kilowatt hours of energy per ton of material upcycled. If you are outside that range, you are not contributing positive to the natural environment. Third one, upcycled products, they have a different composition of fibers, vitamins, nutrients. You have to be at least 80% comparison to the alternative product that you are displacing in the market. So for example, if you are creating flour from spent grains and you are substituting regular flour that is on the market, and that flour has a different composition such that the nutrient present in the other flour is much higher and more nutritious, then once again, you are not positively contributing to the natural environment. And last one is the location. This is only valid within Ontario and Quebec. Otherwise, the energy grid mix would alter the results of the study. Thank you so much. So forget about the slide. The key point here is be careful when you apply linear solutions to complex and nonlinear systems. And third of all, it is important to be context specific. Those are some of the necessary conditions that need to be in place when you upcycle materials.
Thank you, Yuri.
Oh. Sorry.
What's that?
I'm going to save that.
Next will be hearing from Ryan Zizzo, who will take this discussion to the policy. Does anyone need the? No. Okay. Who will take this discussion to the policy level. Ryan has led several major projects on embodied carbon and life cycle assessment, including with the federal government, several provincial ministries, Toronto, and many large private corporations. He is also on Canada's Green Building Council's Zero Carbon Steering Committee. Over to you, Ryan.
Great, thank you. So I'm going to be talking about buildings and policy. My background is in structural engineering. I went to school to figure out how to design buildings. I worked as eight years for a large engineering firm doing LEED certifications across the country. I then moved to Helsinki, Finland for 3 years, where I saw the future of green buildings because they're so far ahead of us in the Nordics. I came back to Canada in 2015 and started my own consulting company working on these issues of circularity, embodied carbon, and life cycle assessment. We now have a team of 11 people across the country working on these issues. I'm really excited to be here and speak to you all. I'll do a quick, brief overview of why I think embodied carbon is important in construction. I'll show you some relevant CSA standards that I want to make sure everyone in this room is aware of. And then I'll quickly touch on some study results for a really groundbreaking study that we just released today. It was just posted this morning. And I will do a quick overview of a brand new Toronto policy that I think you'll all be really interested in. So this is the slide I start with my presentations with when I'm speaking to developers. And I say, when we're talking about operational emissions, we're only looking at the yellow part of that picture. That's the energy associated with heating, cooling, ventilating, and plugging stuff in our buildings. When we're talking about embodied carbon, it's all the other stuff in blue. It's making our materials, transporting them, installing them, reusing them, or replacing our windows or roofs, and then finally all the end of life and ideally recycling those materials. And in new construction, actually, between new buildings built between today and 2050, 50% of the carbon impact of those new buildings are going to be from embodied emissions, and a lot of people don't realize that. So if we ignore embodied emissions, we're ignoring 50% of the emissions of new construction between now and 2050. Why embodied emissions are so important now and becoming more important with time is because of this graph. The picture at the top represents cumulative emissions from a new building. You can see in year one, it's all embodied, right? We've just built the building and we haven't turned on the energy systems yet. So 100% of the emissions at year one are from embodied. But over time, we're heating and cooling the building and more operational emissions are emitted. And over a 60-year period, say, for buildings of the past, at this top example, there's way more operating carbon than there is embodied carbon. That's how buildings used to be. In that situation, how do we minimize carbon? We ignore embodied and we focus on operating. There's way more operating there than not. But that's no longer the case. We've been doing a really good job of making our buildings more energy efficient. Every few years, there's an upgrade to the Ontario Building Code and any other codes across Canada. New buildings today use far less energy than new buildings used to. And the energy they're using is far less carbon intensive, right? We're putting up wind turbines, we're putting up PV panels, we're getting rid of coal. So today, a new building uses much less energy, and the energy it does use is much greener. When you combine those things, this top is no longer the case. The bottom is the case today, where embodied carbon is a huge amount of new high-efficient building. And this is what's been the big policy shift in the past 5 to 10 years, why we really need to be looking at embodied carbon. And look at what happens when we look at smaller timescales. The 10 years on the far left side there, when we look at the smaller timescales to 2030, 2040, embodied carbon is by far the main driver of the carbon footprint for these new buildings. So this is why embodied carbon is so important in construction and will only become more and more important as we go forward. This is another way to show that. In the past, embodied carbon was the red piece of the pie was small, and we haven't really done a great job of managing it. So the other part of the pie, the operating carbon, is getting smaller and smaller. So now we're left with this big red chunk that was small before, but now it's big, or now it's relatively larger. So how do we get around this? How do we reduce embodied carbon in construction? Is we want to, well, obviously, the new materials we make should be lower carbon, but we also want to reuse existing materials wherever possible. So we want to take more of our materials from a place like the left, a salvage yard where we have great, high quality, reusable structural and finishing materials, and less of our materials from a place on the right, which is a high energy intensive production facility. A lot of text on this slide, but these are some key CSA standards on circularity, disassembly, durability. Wanted to make sure everyone in the room is aware that the CSA group has really great standards to help set a common language on this, on what a durable, highly reusable building is like. So I won't go into those, but just to let everyone know that they exist and you should be looking at them if you're in this field. This is the new report that we just launched today in partnership with the CSA group and Canadian Circular Economy Canada, or Circular Economy Leadership Canada, and we looked at what is the carbon impact of doing a full deep renovation on a building versus demolishing and reconstruction. It's available today on our website, mantledev.com/publications. We basically looked at high-rise offices and low-rise offices in Toronto, Vancouver, and Edmonton, doing a full demolition and rebuild versus a deep carbon retrofit. We looked at basically replacing all of the systems like the envelope, mechanical, electrical, plumbing, interior finishes. We figured a deep carbon retrofit is going to have all new systems for those. But if in the demolition and new construction, the difference is we also demolished the structure and rebuilt the structure. That's the main difference in those models. And we looked at how all of the carbon of that embodied and operational and refrigerant leakage, how those all play out over a whole 60-year time frame of a building. So these are all the life cycle assessment phases that you're all familiar with if you're an LCA nerd in the room. And we also took the C phase, the end of life phase, and we did that up front too to account for the demolition and the removals, right? Which a lot of people don't do. So we think we did a pretty robust job of looking at the full life cycle here. And these are what our results found. So you can see across the board, the embodied carbon, that gray thing at the gray box at the bottom is much smaller on the right side, which is the retrofit cases. And you can see the text in the pink there. Upfront carbon, in this example, a Toronto mid-rise office, upfront carbon was almost 70% lower in the retrofit, and over up to 2050, the total carbon impact was still 40% lower for that renovation case. So these numbers vary a little bit depending on region because of the different electricity grids, but generally speaking, we found that regardless of the scenario, it was always a better carbon option to renovate if you're doing a deep green renovation. And we found these were our ranges here, that the upfront construction difference in those scenarios were about 51 to 76% carbon savings. And by 2050, the results were 11% to 58% lower. So the 11% was in Alberta, the Edmonton example, because in that region, the operational carbon is so high that the relative savings in the embodied was a smaller share of the total. So that's why that number was relatively lower, but still we saw the same results across the board, that it's much better from a carbon perspective to do a deep green renovation than to demolish and rebuild. Some other interesting findings was that these regions with greener electricity, it had a larger relative impact on the carbon of the building. So BC, Quebec, Manitoba, Ontario, Newfoundland, PEI, we should really be doubling down on renovations in those regions. We also found that if we need to do a new construction, then really we need to be focusing on low carbon materials, and also we can use bio-based materials like mass timber. And if we account for the carbon, the sequestered or biogenic carbon that's stored in the mass timber within the wood, then the numbers actually come out to be very similar between a deep green renovation and a bio-based building if we're accounting for that stored carbon. And just wanted everyone who's not from Toronto to know there are two big mass timber buildings going up right across the street over there, a little bit east on Queens Quay. If you go out for lunch, go take a walk. You'll see one of it is beautiful exposed mass timber, and we helped George Brown College with that building as well. So that's a whirlwind. This is, I think, my final slide. Wanted to tell you about this Toronto policy that was just passed May 10th, a month ago. It makes Toronto the first municipality in North America to set embodied carbon caps on certain types of new construction. So it was an update to the Toronto Green Standard version 4, and now any city-owned building in the city needs to calculate its embodied carbon and be below those numbers you can see in the graph, 350 kilograms of CO2 per meter squared for all city construction, and they have a higher efficiency tier. And those are tier 2 and tier 3 in the Toronto Green Standard, which mean that they're voluntary for non-city owned buildings. But the trend is tier 2 becomes tier 1 in a couple of years for everyone else. So this to me means the writing is on the wall that every building in Toronto is gonna have to meet these embodied carbon caps. They're gonna have to limit their embodied carbon, or else they're not gonna get a building permit within the next couple of years. So thank you for listening.
Thank you. Great. Thank you, Brian. Next up, we'll be hearing from Darryl Moore on circularity benefits and awareness for it. Darryl has been engaged in circularity across the economy, having worked with Fortune 500 companies, SMEs, NGOs, and now instructing at Cape Breton University. Darryl is also currently focused on the circularity of rubber in particular at Kaltire. And I'd recommend checking out Kaltire's booth outside to hear about the fascinating story of rubber as a history of ecosystem services, colonization, electrification, and common ground with oil and gas sector workers. Thank you.
That was awesome, thanks. So I don't need to tell you where I'm from or who I work for. You're going to hear about tires. And I apologize. But first, for those who are parents, you don't want to admit it, but you have a favorite child. And I have 2 children that I deal with. One is called natural rubber. He's fantastic. He's all natural. And the other one is synthetic rubber. And most of you came on tires, and you mostly came on synthetic tires. Natural rubber is the workhorse of my family, and it does transportation. It does mining. It does forestry. And when I'm talking about rubber today, I'm talking about natural rubber, because synthetic rubber, the child is nothing but oil and squeak. This one here is the workhorse, and it's where the opportunity is in circularity, or at least where we're investing in understanding what that is. So when I talk to customers about circularity and about rubber and tires, I'm talking to the transportation industry, and they are not the most evolved industry. So I make things as simple as possible. I'm going to show you some simplicity here, because some of them don't even know what net zero 2050 is. Some of them are surprised when I use the word circularity or sustainability. They're still talking about corporate social responsibility. And so we help move them to the future by giving this conversation to them, which also benefits our relationship overall. So this is the amount of pounds of tires in a decade that come into Canada. So about 1 billion pounds worth of tires enter into Canada. We don't manufacture many tires, and that means we don't get the manufacturing benefit. Tires come here to die. And so when we have that much waste, we have to look at it as a resource, and we haven't, and it's been very difficult to do. This is what one commercial tire, and if you want to see a commercial tire, we have one out there, is worth by weight of single-use water bottles. Now, none of us walk away from a single-use water bottle. The one on that table, that's mine. I'm taking it with me. I refill it. It's treated well. But we don't, and we frown upon anybody who throws away a water bottle. Yet a single-use tire is purchased and disposed of very, very quickly without a second thought. And we need to move the understanding of a better way to use tires overall. And that's what the calculations that matter to customers in the transportation industry are all about. We don't necessarily, if I used things like a fundamental shift in something, I would lose my audience. If I used some of the equations that you've seen today, gone. They wouldn't invite me back. So we have to make it really, really simple. So this is, I'm going to throw up the LCA, to which you guys are awfully familiar with, in simple terms. So you get the materials, you transport them, you manufacture something, you transport them again, and they get to retail. And that's the cradle to gate. And we measure that for our customers so that they can start understanding their own movement and choices, because it is choices. It's about a single-use tire versus a tire that can be technologically used for other things like retreading, devulcanization, thermal conversion. This system goes, right now, is very linear. A tire gets shredded into buffings, those buffings gets transported, it becomes a second product, and then it heads down to landfill. And sometimes it's spread as mulch in your yard, and sometimes it's burned within Canada. 17% of all tires are burned as a substitution for coal. So when we have, in a life cycle analysis, I show this little red line, and maybe I can move it to highlight it, that is kind of the point of no return. There's no recycling body, no municipality that collects rubber. It all goes to landfill. And so in such, all the rubber gloves, all the rubber-based products, everything that we use, including tires, heads to landfill. So we want to capture it before the point of no return, and that's within the collection system that exists now. And then we can start applying circularity to it. So the first one would be retreading. The second one would be devulcanization, and the third one would be thermal conversion. And through those 3 circular loops, we can get to what is the best use of tires before they head down the path, becoming another product. Having said that, how do we make that relevant? And so in the use of the life cycle analysis, we do our best to calculate the carbon based on the choices that our customers are making in their tires. So for our customers, we're a scope 3. Right, and they're busy, if they're lucky, they're busy on scope 1 and 2, and they're not too worried about scope 3. But what they do become very aware of is that if they have a measurable piece to give them actual calculations around the carbon footprint of their tires, they will start making better choices. And we've gone to our customers, those who are using single-use tires, we've gone through and shown them how they can now measure via a carbon footprint, and it becomes equally as important to them, because they don't know if we don't tell them. And that's the state of a lot of industry right now, is that we have these high-level conversations here, and it's fantastic. We learn a lot, but translating it to our customers, particularly in old school industries like transportation, where they're high emitters, is a very challenging thing. So we build in and we update the LCAs and the calculations, which then become certified so they can have some kind of relevance to them, and they can start using them to make a better choice. And the choice always is single use versus something that allows for circularity. And so we can go back to our customers over and over again, which is why when we talk about natural rubber and we talk about the commercial tires, mining tires, those big, big tires, we do have a solution for circularity. And it's 3 levels of circularity: retreading, devulcanization, thermal conversion that can take us there. It's really about the adoption of that within the system, and that's about understanding and educating. And so when we talk about numbers, in our case, the numbers that matter, the calculations that count, are the ones the customer can understand. Because when we were going to them and said, you've saved 69 house days of energy, or you put something in those ambiguous, they can't do anything with it. But when you give them kilograms or metric tons of carbon and measure that year over year and they see change, they can go back to their board. They can go to their customers with it. They can write an RFP, and that becomes meaningful. And that's the calculations that we do for our customers so that they can start to understand. And I would encourage those who have the influence to do the same thing. If you've done LCAs, don't protect the data as much as you might want to. Use it with your customers to help them make better choices. And if we do that, we'll move a lot faster. That's it. Thank you.
Thank you, Darryl. Now over to François Saunie on circularity with iron and steel in Quebec. François has experience from life cycle assessment in several fields, including mining and metals, chemical processes, agribusinesses, and buildings. He's also participated in the development of complementary tools such as material flow analysis, circularity indicators, and courses on life cycle assessment. Welcome, François.
Thank you for the introduction. So I'm going to present you the results of a project that we did a few years ago on the link between GHG emission and circular economy in Quebec. I took the case study on the iron and steel value chain, but we also studied other products, concrete, aluminium. So I'm kind of a guy of numbers, so I will try to use no numbers, no equation, maybe one equation, just some figures and to be short, so cut me if you need. So to study the link between GHG emission and circularity strategies, and to know where circularity strategies could affect and reduce the GHG emission, the first thing that we did is really to have a good understanding of the life cycle of steel in Quebec. So we start from the extraction of iron ore up to the end of life of the steel. Once we know the life cycle of steel, in what kind of product we will use the steel in Quebec, where are the industrial activities, what are the end use of steel in Quebec, then we want to have a better understanding of the flows between all of these activities. So this is the results of a material flow analysis that we did on iron and steel in Quebec. So what we could see is that we are extracting a lot of iron ore in Quebec, but just exporting it. So circularity strategies in Quebec won't touch this part, or we will see the results, but we are also importing a lot of steel from outside for our needs. So when we will implement circularity strategies on the use phase, for instance, we will affect both flows of steel in Quebec, but also outside of Quebec. So this is for the flows, but when we want to study the effect on circularity strategies on the economy, we also need to have a better idea of the stocks. So the stocks of iron in Quebec are in 2 places. We have the deposit that we are extracting and that we want to extract less and less if we want to have a circular economy. And then we have the urban stock at the use phase. So we have still in vehicles that are in use, still in buildings, and with circular economy, what we want to do is to optimize the use of steel in this stock. So we will see some strategies that we assessed. And this stock is really increasing year after year. We had discussion about growth and the fact that we consume more and more products. So once we know the flows and stock of steel in Quebec, what we did in our study is also to assess the GHG emission related to these flows and stocks. So the first GHG emission that we could assess are direct GHG emission. So at the mine, at the steel making plant, we have direct emission from the transformation of the ore up to the steel. And then during the manufacturing activities, we also have some direct emission because we need energy to make the steel products. We also have emission at the recycling, and we had some discussion and presentation before that recycling is not net zero, so it's also something to have in mind. So we have direct emission, then we also have indirect emission. And in fact, most of the time, indirect emission could be higher than the direct emission for several products. So when we talk about indirect emission, we talk about the production of the material that we will need to produce the steel. So at the mine, I will need to produce explosives to extract the ore. So I will have indirect emission related to the production of these chemicals and other products. I will also have indirect emission related to the production of the natural gas that I will need to the steel reduction at the plant. And this natural gas is produced outside of Quebec. So there we could start to have an idea that some circularity strategies will lower the GHG emission in Quebec, but will also affect the GHG emission outside of Quebec. So from a global perspective, is really good. You want to reduce GHG emission everywhere. If I'm a policymaker that wants to improve GHG emission in Quebec with the use of circular economy, maybe some strategy will be better than other ones if I'm just looking at the Quebec or my region in terms of what kind of strategy I could implement. So two types of emission, direct and indirect emissions. And then I could also consider in my study the indirect emission related to the use of the steel. So if I consider a car that part of the car is made of steel, I will need fuel to move the car. So I could allocate some of the emission of the car to the steel that is in the car. And we will see how it could be used to assess the potential of GHG emission reduction from the implementation of circularity strategies. So as for the production, we have indirect emission that are in Quebec in the use of the car, but also indirect emission outside of Quebec. The production of the fuels or the extraction of petroleum that will be used by the car will be also outside of our boundaries in terms of emission. And then the last category of emission that we could consider are the emission from the production of the steel that we will import. As I mentioned before, in fact, in Quebec, most of the steel that we will use are coming from outside of Quebec as semi-finished or finished product that we will import. So we will buy a car that has been made in Ontario or in Japan. We will also, maybe for the building sector, we will buy some products made from steel that are also coming from other provinces or other countries. So it's good also to have an idea of the impact of this, the emission related to the production of this material that we import. So this is for the first picture of the link between flows and GHG emission in Quebec. Then the only question of my presentation, what kind of circularity economy strategy could we apply to reduce the GHG emission? In our study, we consider three types of emissions, three types of strategies. The first type of strategies, we looked at the amount of GHG for the production of 1 ton of steel. So first categories of strategy that could lower the overall GHG emissions. Then we have strategy that looked at the quantity of material that we need per product. So lower the quantity of steel per vehicles or of steel per buildings. And then we have strategy that looked at the quantity of product per service. So so lower the quantity of car needed for 1 kilometer, for instance. And if we apply all these strategies to the previous picture, we have the potential of reduction of GHG emission in Quebec and outside of Quebec from the implementation of all these strategies. So in light color, you have the potential reduction for the application of the 6 strategy that we studied. So we could see that reduction could be both inside of outside Quebec, could be both to direct and indirect emission. So I don't have the time to explain more the figure, but if you want to know more about the study, there is a report on this that unfortunately is only in French, but a lot of the actors of this study are in the room today, so if you want to chat after, feel free to come and I will be there to discuss. And we also published an article that is presenting the methodological approach. So all that I did there could be done on other regions, other sectors, other materials. It's just a question of having the right numbers to do the study. So thank you, and feel free if you have any questions.
Thank you. Next, we'll be hearing from Sayegh and Daeun Yoon on construction, or rather deconstruction. Leanne began her career in structural engineering for buildings and now applies her rigorous structural understanding to the impacts on the environment. In her work, Daeun has a particular focus on circularity, decarbonization, and holistic sustainability frameworks, and brings additional knowledge through the certification as passive house designer and envision sustainability professional. Over to you both.
Thank you. Okay, so today we'll be presenting a deconstruction case study. So the overall project involves the deconstruction of an existing building and then the new construction of a new building on the same site. The Arup mandate focused on the deconstruction aspect of the project. And our goal was to showcase to the client deconstruction and material reuse as a decarbonization potential for existing buildings in terms of embodied carbon management and resource management. So for our deconstruction assessment, we based ourselves on the 9R framework, where from R9 to R0, we increase in circularity. And so by using this framework, it helped us assess the existing materials and with the aim of retaining their highest value. We also use the shearing layers, the concepts of the shearing layers for the deconstruction feasibility. So as part of our assessment, we created a roadmap to circular scenarios. We wanted to provide this to the client as a decision-making tool, but we also wanted to present key concepts such as safety, design states, feasibility, and impacts. So this was really the evaluation framework that went into the analysis of the materials, of the existing materials. And so we really wanted to improve the circular improvements and to move away from business as usual. So the carbon assessment was actually done in the impact benefits, and Daeun will speak to it.
Thanks, Leanne. Oh, okay. Thanks, Leanne. So let me walk you through how we broke down carbon of evaluating demolition versus deconstruction. So you've all seen this LSA slide before, so I won't dwell too long on it. But really the overall objective here was to evaluate the impacts and benefits of deconstruction. And the goal here was to make this project better than a typical demolition project. So focusing on carbon, we looked at the product stage, so the A1 to A3 emissions, end of life stage, the C1 to C4 emissions, and also the D module, benefits and loads beyond the system boundary. So starting off, we looked at what was embodied within the existing building. And this was really important to evaluate to see where the potential savings could lie. With this specific building, the embodied carbon was within the rebar, concrete, insulation, terracotta bricks, and structural steel. And so we knew which materials to prioritize for reuse, repair, remanufacture, and other 9R recommendations. Second, we looked at what the current business as usual scenario is for these materials at the end of life. We found most of these materials, unfortunately, go to landfill. However, a handful of them are currently recycled, so we took into account the benefits and loads beyond the system boundary. And finally, we're all here to hear about deconstruction. So we looked at the material salvage and reuse potential of each of these priority materials. And we found that there is actually a high potential of savings of embodied carbon. We also took into consideration the end-of-life impacts for deconstructing the building as well. So let me walk you through an example. This is an example of structural steel that we assessed in the building, and this is based on the quantity and the carbon intensity of steel, as you've seen in the presentations before. And in the business as usual scenario, we found that steel is currently recycled, so we took into account the end-of-life emissions as well as the benefits of recycling steel. The net impact was actually a carbon savings of 12 tons of CO2 equivalent for the business as usual scenarios, which is pretty good, but we wanted to make it better. So we recommended reusing the structural steel instead of recycling it. So we took into account here again the end-of-life emissions associated with deconstructing it, but also a significant improvement in the carbon savings of reusing rather than recycling it. So with this, comparing the R3 scenario versus the R8 recycle scenario, we're saving 5 times more carbon by proposing this. So just to close off our presentation here today and just summarizing our methodology of breaking down carbon of demolition versus deconstruction. First, we want to evaluate the existing embodied carbon within the existing building. Second, we want to look at the business as usual scenario of what these materials look like at their end of life. And finally, we want to evaluate the potential savings of deconstructing the building. And it's really important, we found that by deconstructing the existing building, that this is a really impactful and very valuable methodology and circular economy pathway, but also a socially responsible pathway of thinking of materials at their end of life and really think about how we're allocating our carbon budget in the built environment. Thank you.
Thank you, Daeun and Leanne. And next we'll be hearing from Julian Cleary. And we're running a bit behind time, so any material efficiency would be appreciated. Julian will tell us about procurement and the tools to get it right. As you may have heard yesterday, Julian's first author on life cycle assessment, same mistake as yesterday. Julian's life cycle assessment articles on which he's the first author have gotten over 800 citations, including from the likes of the IPCC and ECCC's National Inventory Report. Over to you.
All right, thanks so much. So I don't know if I'm really going to go through all the slides here, but what I want to tell you about, I think that this project that Public Services and Procurement Canada has been undertaking over the past 3 years that I'm managing now. The Low Carbon Procurement Project is quite an exciting one. It's one that essentially has 2 prongs. One that gets into better measurement because currently the greenhouse gas inventory that the Government of Canada has is based on an environmentally extended input-output model, which is really fantastic for being able to identify essentially average emissions for generic product types. But the thing is that this model, essentially you input your spending in various categories, office supplies and other things. So it's not really the right tool to be able to estimate your actual effects of green procurement. And this is what this low carbon procurement project is going to do. It's going to improve our greenhouse gas baselines in particular categories. And use the information that we'll be collecting, or that we, that we could potentially be collecting from vendors to actually produce a low carbon benchmark that will allow us to be able to identify low carbon products versus their higher carbon alternatives. So anyway, let's continue. Is this how I go forward? All right, great. Sorry, I was very low key at the beginning. I will try to get to more of a higher, more energetic level. Maybe I should have had a coffee before this. Anyway, so yeah, I'm going to provide you the context and an overview of the LCPP and its objectives, and present the methodologies and tools developed by the LCPP per product category. Now, just to give you a bit of background, so hey, we are a really big procurer. We spend $30 billion every year. PSPC, my home department, is responsible for $24 billion of those dollars. More than half of the money goes toward professional services. Now, the low carbon procurement project, it was a project that was funded by the Treasury Board Secretariat's Greening Government Fund over 3 years, $700,000 that we received in order to produce 3 carbon footprint methodologies in 3 high impact categories, and then to use this information to be able to produce better greenhouse gas baselines and to be able to better distinguish between high carbon and low carbon products, so that we can actually have some incentives to be able to essentially green what we procure. Now, year 1, generally a literature review, looking through best practices, picking which ones would be the optimal the optimal categories to choose for these methodologies. Year 2, development of the methodologies. Year 3, developing the greenhouse gas footprint tools and stakeholder engagement. So what are the 3 categories that we chose? First of all, office furniture is an area where there has been a lot of work already done. There have been a lot of product category rules for to produce EPDs, or environmental product declarations. So around 60% of the furniture that we procure actually already have EPDs associated with them. Light duty vehicles, we have got light duty vehicle targets, a very ambitious one where 100% of our the Government of Canada's vehicle fleet will be zero emission vehicles by 2030. And if the average vehicle lifespan is 7 years, we got to do things now. So there's that. Professional services, hey, it's the largest category in terms of spending. So that was the 3rd one that we chose. All right, in terms of office furniture, let's get into the methodology. This one, we developed it with the support of WSP Consulting, to essentially align with BIFMA, the Business and Institutional Furniture Manufacturers Association. They put together PCRs, or product category rules, for workspaces, for seating, for storage, and we put together actually what I consider probably the most sophisticated greenhouse gas calculator for furniture around. That was put together in Microsoft Excel, where essentially let's see. Here's a quick look at it. It's got a lot of worksheets. It's got some a lot of pull-down menus and emission factors, where essentially the vendors would be able to essentially put in the details about their about the their energy use materials and so on, and then the emission factors would automatically convert that into an overall carbon footprint. There's a data quality assessment as part of this tool. So here's just a quick look at that. In terms of light-duty vehicles, that is something where we did something fundamentally different. The vehicles are some of the most complicated products that you can procure. They have thousands and thousands of parts coming from many different places. So in fact, what we decided to do is to work with the National Research Council, who put together a really excellent life cycle assessment model that in fact, it shows their publication in Journal of Cleaner Production. Well, we decided to ask them, because the way it was designed was not really good for procurement. So we asked them to adapt this model, first of all, to move it from a commercial LCA software into an open source one, OpenLCA, but also to be able to compare by vehicle model, and because the way it was only the average passenger vehicle. We wanted to have different sized vehicles. We wanted to have pickup trucks, SUVs, and essentially sedans, and that really goes over most of the light duty vehicles that we've got. And then we changed we parameterized, or the NRC parameterized the model, so that we could actually just, if and when we use this model, the vendors will not have to know how to use the life cycle assessment software. All they would need to do is just enter in their figures into an Excel file, and then be able to, and then the program would automatically be able to read those and then provide the carbon footprint. So I think that this is, I probably have, my 6 minutes is probably up. So I fit as much as I could in here. So I think I'm just going to go to, the potential phase-in approach. So what we're hoping to be able to do is to use these as data collection pilots next year from contract suppliers. Year after that, then to be able to use this collected data to be able to produce greenhouse gas baselines and low carbon benchmarks. And then the following year, we're gonna sort through the flaws and make it as optimal as we can, and hopefully we'll be able to do some, have some major incentives for low carbon procurement in these categories. But but there's a lot more plans than this. But I can't fit everything in 6 minutes. But hey, if you want to know more, I did a presentation yesterday that was 15 minutes long. Actually, it was more like 17 or 18 minutes long. Download those slides, and you'll get more information. All right? Thanks.
Thank you. Thank you, Julian, and thank you, all of you, for such concise presentations of such incredibly complex information. It's really a feat. Well, we have time for a couple questions. And while the mic finds someone in the room, there's one question on the app with 4 upvotes. How do we bring about degrowth when success is measured by GDP? And I'm going to add the implied question, how are we doing in measuring alternative metrics of social well-being and including that in assessments? I'll throw that to you for having mentioned degrowth, and then for Julian for mentioning other types of impact yesterday.
Was the question, how do we bring about degrowth when everything's measured by GDP?
Yeah, and then how are we doing in other alternative measures? And keep it brief if you can.
I'm not an expert or a researcher in degrowth. It's an interest of mine. So, and in fact, the model that I presented today works on a typical GDP sort of growth scenario. So there's nothing in there about degrowth. So I can't really comment on how we make the transition. But yesterday, when we were voting on these words that we associate with circular economy, and synergy was one of the top ones, and holistic was another one that I saw popping up there on the app. And like these are words that describe degrowth. Like degrowth is about transforming, and I think circular economy is very similar in concept, but it's taking pieces of the puzzle rather than taking a transformative approach. And so that's why I suggest that we need something that's big picture, that's about changing the system, and circular economy will be part of that, but it needs to be from that bigger umbrella.
Okay, thank you. Julian?
No one can hear. Okay, now people can hear me. So hold on. The question was about metrics other than climate.
Other than GDP.
Other than GDP.
Yeah.
You're saying. Well, don't give that question to me. I don't know. No, I mean, you know what? Can I say pass?
Sure. Go ahead.
I could comment on that. I think based on something Julian said, which was really important, which was don't use finances to estimate your carbon footprint. Right? He says that's what the government was doing before, and that's what we did with a big developer we're working with to help them calculate their Scope 3 emissions. But if you're measuring your carbon footprint based on the dollars you're spending, the only way to decarbonize is to spend less money and do less business, which is not a recommendation we're giving our clients, right? So you want to calculate your carbon footprint based on the actual materials you're procuring, not on the dollars that you're spending on those materials.
Yes, what he said. Ryan, thanks. Thank you so much.
I got you.
Thank you for rescuing me.
François, is this burning, or do we have time for a second question?
Just because I disagree with what he said.
Bring it on.
Right, let's go.
Because we did the study on estimation of the carbon footprint of the procurement of Canadian government based on dollar. And if we want to do the same study using numbers, we don't have the data to do it. I mean, we can't quantify the numbers of each nails and et cetera that the government will buy to construct the building. So what the study that we did is good to have a first scoping of the overall emission and to highlight where are the main sources of emission in the government. And then we could move to physical flows and specific buildings and data. But I think the economic first study is also useful to have a first assessment of the whole procurement of the
We have to
government
collect
of-
better data.
So then we could work on refining the economical model that we are using, and it's what we are doing in our research center, is really to refine the model to have a better overview, more sectors, more information, but I think we should not say it's useless. And
Oh no, it's not useless, but we need to do better.
We need both approaches.
More data, sounds good.
I think the question was really challenging us and pushing us in a different dimension. Probably we don't have the answer, but GDP is capturing only transaction in the throughput measure. It's not a measure of the value that is already nested in society. We don't have that measure, and so we need to think about what does it mean to quantify? What does it mean to measure? We can quantify a lot. We might not be able to measure a lot, and then we need to question, do we have to measure in order to act in a certain direction? Because some are just impossible to measure certain dimensions. So spend time outside this panel to have a beer with you guys and build relationships. Those relationships are not going to be useful maybe for the next 3 years, and maybe something happens that requires me to reach out to some of you, and I have that relationship, and at that point, in that context, the relationship becomes valuable. How can I capture it? It's not. So I think it goes back to what we are trying to achieve. Are we trying to achieve a low-carbon economy, or we are trying to achieve a resilient economy? If we are trying to achieve a resilient economy, then we should invest much more in social interactions. We should invest much more in family time, because those have value, and that value manifests sometimes in our life. And we need to appreciate those moments, even if there is no quantification possible for some of them. So I think the question was really provocative, and I'm in a business school, so don't take me wrong. We are here because in the 60s, someone decided that the business school of the world had to teach the importance of shareholder value and profit maximization. Now we just met at the United Nations to think about what can the same network achieve if we change the goal of what we teach in those business schools. But I think we need to say for some dimensions of prosperity, such as carbon, we can get to a fairly valid measurements. For some other dimensions, we cannot, and we should be thinking about qualitative ways to consider those dimensions in the equation.
Thank you. Thank you for all the insight. I think we have time for one question. Yes, who do we have? Please.
Can you hear me? Oh, yes. Carolina Seward, Environment and Climate Change Canada. Super interesting discussion on sufficiency and degrowth, but I'm going to change the subject. Although I would point out the Government of Canada does have a quality of life framework. Maybe we could be pushing to use that more. TBS, Mona Fortier mentioned it this morning. In terms of my question, I wanted to ask about supply chains and emissions. And I think, you know, with COVID and all this talk of reshoring and Yuri, your work, I'm wondering if you guys are getting a bit of a picture of which supply chains make sense to remain global and which supply chains really should be becoming more regional or local in terms of their emissions impacts and versus, you know, delivering quality and affordability. Like, do we have a sense of how do we optimize supply chains at what scale?
Yuri, I'd like your opinion, but first I'd like to offer Darryl, Leanne, Daeun, if there's any thoughts you'd like to give you the chance to answer this question.
I have no mic. It's right here. No, I have no mic.
Gotcha. Due to technical difficulties, Leanne, Daeun, is there anything? All right, yeah, Yuri, what are your thoughts on supply?
So,
definitely comes up a lot when it comes to measuring.
We have a partnership with CSA where we are doing the same work that we did in agri-food to generalize beyond agri-food and look into materials in the construction sector and in the fashion sector. So we're going to do the same type of analysis, the necessary conditions for those supply chains to be ecologically impactful, positively impactful, for wood, for polyester, for cotton fibers, and for, I think, cement. and the last one, I don't remember right now. But so we are trying to generalize. What I'd like to say is two things. For agri-food, it's fairly clear from what we have seen that we should be working towards regional scale supply chains. We have also experienced the importance of that regional scale resilience during the pandemic. And so for agri-food and organic materials, I would expect a regional to local scale to be optimal. As we expand to minerals and to plastics, they usually have a higher embodied carbon in them, then I would think that international supply chain can still be meaningful and useful. But I would also say that what I learned, and I wasn't aware of it as I started to do all this work, is always a relative comparison. So all supply chains emit carbon. There isn't one that doesn't. Or there are a few that are regenerative and play with natural systems, but we don't know how they function yet. So when we say that, for example, an upcycling supply chain for a new type of flour that use food waste is carbon neutral, what we are really saying is that that supply chain emits a certain amount of carbon, but sourcing that flour through a traditional supply chain would create more carbon. So you are saving in relative terms, but not in absolute terms. So as we move towards circularity, the baseline will change. Therefore, what is now better at a regional level, because you are competing against a global supply chain, so you can exploit carbon differences in that comparison, will not be so in the future. And so it's going to be a progressive effort. It's going to be a progressive effort. And right now, I think certain materials work better at a regional level and some materials better at international level. As we work towards circularity, we need to reassess that because the scale should change again.
Maybe if I can just add to that, I would also say in the construction world, we don't talk necessarily about a regional supply chain, but getting from low carbon regions. If you're in Alberta, I don't want you to get steel from Alberta, even though it's close by, because you have a really dirty grid. I want you to get steel from Ontario, where we have a really low carbon mills in Hamilton, right? So purchase your materials from places that make them in a low carbon way, and a lot of times the transportation is a much lower amount of carbon than manufacturing it in that low carbon grid.
And can create demand stimulus for those provinces to invest in alternative materials, because if your customers are going away to another province, then now you have an incentive to improve your local technology.
And I go back to we need better data, right? I have a steel fabricator client based in St. Catharines, Ontario. They buy their materials from a steel supplier, and they don't know where the steel supplier gets the data from or gets the material from, where it's manufactured. So you'd think it would be very easy for them to understand what their carbon footprint is, but because there's a number of layers between, we don't have good visibility as to the actual mills they're coming from. So for me, it all goes back to we really need better data of what we're making and where it's coming from.
Yeah, I definitely think better data is a key takeaway from this conference. And I see people coming in through the door, so I think that's about sign of time. Again, thank you so much for going through so much material so quickly, which sounds weird to say at a circular conference, I realize, but big round of applause for our amazing speakers. Thank you.